The next thing we want to look at is we want to look at this thing called proportional reasoning. Now you've done proportional reasoning since junior high math, but what we'd like to do is we'd like to actually put it in the context of physics. And these are actually really common questions. You can always expect these on exams, especially in Physics 30. We really love to do proportional reasoning. So what we'll do is we'll say, in this context of Newton's law of universal gravitation, we'll say, the force of gravity between two objects is, 5 newtons, let's say. Now the mass of this thing doubled, the mass of that thing tripled, the distance between them was cut in half. What's the new force of gravity? So what we're saying is we have a quantity that's measured, and then we're going to tweak the variables a little bit, and then we want to see after the tweaking of those variables, how has that measured value changed? Now I'm going to go through 3 proportional reasoning questions. The first one, I'm going to show you 2 methods on how to do it. There's what I would call the formal math way, and then there's the second way, which is kind of the shortcut way. For the second and third ones, I'm going to do more of the shortcut way, but whichever method you prefer, it's all good. So I'm going to put method 1 here, method 2 here. So let's see what we got. So gravitational force between objects A and B, it's exactly 5.00 newtons. So now suppose we decide to double the mass of object B. We want to find the new gravitational force between A and B. So the first one is the very formal method. So we know that Fg is going to be this G mass A mass B over R squared. And we're told that this is exactly 5 newtons. Now, what we know is for this new force of gravity, MA has not changed. G has also not changed because it's a constant. But this time, we've doubled the mass of object B, and we're going to divide that by R squared. R has not changed. Now, multiplying, the order doesn't matter. So I have G times MA times 2 times MB. Why don't I just pull the 2 in front? Nothing wrong with that. So I got that 2 in front. And then I got this G, MA, MB over R squared. Well, hang on a minute. With the exception of that 2 being there, that G, MA, MB divided by R squared, we've just said that this thing here is equal to 5 newtons. So really what we're saying is our new force of gravity is twice times the old one, or 2 times 5 newtons, which is just going to give us 10 newtons. So by doubling one of the masses, we've doubled the force of gravity. Makes sense because the force of gravity is directly proportional to the product of the masses. So we double one mass, we're going to double Fg. That's the formal math way. The kind of I'll say the easier way of doing it is we want to look at the factor by which Fg changes. So what we're going to do, so we know that Fg, we know that it's equal to 5 newtons. So for Fg new, what we're going to do is we're going to replace all these variables either with 1s or a number that's not 1. 1 is going to be reserved for things that are constants or not changing at all. And then anything that's changing, we'll put in by how much it's changing. So we'll go through this step by step. So G is a constant. It will not change. We're just going to put that in as a 1. The mass of A has not changed, so we're going to put it as a 1 because it's not changed. We are told that the mass on B doubles. So what we're going to put here is we're going to put a 2 here to represent that it's doubled. And then the distance between them has not changed. So we're going to put a 1 and we're going to put a square. So we have 1 times 2, which is going to give me 2, divided by 1 squared. This is going to give me a 2. What that 2 is telling us is the factor by which Fg changes. So the factor by which Fg changes. So what does that mean? Well, what that means is we're going to take our original value of Fg and we're going to multiply it by this factor. So think of this number that you get as sort of a multiplicative factor. So what we could say is that Fg New is twice times the old one, which is also going to give us 10 newtons. Same answer as with the first method. This one I find, for those of you that don't really like having a lot of variables around or get a little intimidated by it, I find this method a little bit better. But which one you want to use, I am okay with that, and I'm pretty sure your physics teachers won't mind. I'm going to stick with method 2 for the next two examples just because it's quicker and cleaner. So the gravitational force between objects A and B, we're told it's 8 newtons. Now we want to reduce the distance between A and B by half, and we want to find the new gravitational force. Alright, so we are told that Fg is 8 newtons. So Fg new, well, let's look at what's going on. So we know G is not changing, and neither of the masses are changing. So MA and MB we're just going to leave as 1s. But we've been told this time that the distance between them is now 1/2 of its original value. So we have that 1/2 there. So up top we got 1 times 1 times 1, which is just 1. Now in the bottom, the common culprit, the square, don't forget it. So we have 1/2 squared, which is just going to be 1/4. Well, 1 divided by 1/4 is just going to be 4. So this 4, that is my multiplicative factor. That's how much my original Fg changes. So it's changing by a factor of 4. So what we could say is that Fg new, it's 4 times my original force of gravity, which is going to be 32 newtons. So what that tells us is if I have the distance between the two objects, the force of gravity is going to go up by a factor of 4. So with that r squared relationship, changes in that r are going to be very noticeable in the force of gravity. So let's do one last one. Let's pull out all the stops for this one. So we're told that the force of gravity between A and B is 1 newton. Now we're going to triple the mass on object A. We're going to reduce the mass of object B to 1/3 its original value, and we're going to quadruple the separation distance. So again, quadruple, it means it's going to be a factor of 4. So let's have a look at what we got here. So we got Fg, this is going to be equal to 1 newton. And we also know again that Fg is G mass A, mass B divided by r squared. Let's do our little factor method here. So the new Fg, okay, so we are told, well, G is not going to change. Anything that's a constant doesn't change, so we're going to put it as 1. We're told the mass on A triples, so we're going to put a 3 here. We're told that MB is 1/3 of its original value, so we're going to put a 3rd here. And then down in the bottom, we are told that the distance is going to quadruple. So we're going to have this 4, and then we're going to have this squared. Don't forget the squared. So up top, I have a 3rd, 1 times 3, which is 3, multiplied by 1/3. I'm going to have 1 up top. And then the bottom, I have 16. What this is telling me is that based on the changes I've made, I have to multiply my original force of gravity by 1/16. So to get that new force of gravity, we're just going to say it's 1/16 times that 1 newton. So it's going to be a 16th of its original value. So we do 1 divided by 16, we're going to be about 0.0625 newtons. So based on tripling one of the masses, making one of the masses 1/3, and quadrupling the distance, the new force of gravity is 0.0625 newtons. So the masses, the changes of the two masses, they actually canceled out each other, because by tripling one mass and making one mass 1/3 of its original value, if we multiply that together, it comes back to 1. So changing those two masses didn't do anything. It's that changing the distance that really changed this. Or it's the changing of that distance that actually changed this. So proportional reasoning, they're great questions. We try not to make them too hard. Expect to see them on assessments. And for those of you that do Physics 30, definitely expect to see it there.